Hello everybody, my name is Craig Bennett and I'm the founder and owner of TechFuseNope, and today I am going to get into another CCNA deal, and this is going to particularly be on subnetting. Now this is going to be very complex and very detailed, so if you don't understand IP addresses, this might actually help you out on understanding IP addresses a little bit more. But for the most part, if you're just going to hang around and not really going to get too deep into this stuff, I'll just advise you to skip this unless if you really are interested into it, because it gets very complicated very fast. Now, if you're going to get your CCNA, I'll advise you to stick around because you have to know this. You will be tested on this within the CCNA, and if you're going to go into workplace, into networking or hacking or something like that, then you need to know this, especially with networking type of work. If you're going to go in for a home place, like say for example if you want to learn how to modify your home network, this, chances are your home network's never going to be big enough to really bother with a subnet. So what I would say is just don't worry about a subnet for a home network. So if you're just going for a home network, trying to modify and tweak your home network to be as best as it can, I'll advise you to check out some other videos. But as far as this goes, this gets very complicated very quickly. I will try to put a table of contents up that way, because this is going to be very long. There's no way I could cut this short, and I have to make it as long and as detailed as possible. But I'll put the table of contents up, so if you can't get it on one session or you need to come back to a particular part, then we can go through that, and you can just select which part. That'll show up after the advertisement, by the way, and there's a skip button on the advertisement, by the way. But anyways, as far as things goes, and what I would advise you to do, by the way, if you really want to take this stuff serious and you don't think you can get it all in one session, when it gets to the point of the table of contents, which will be up for a few seconds, what I'll advise is go down, click on the share button, and make sure you say start at whatever time, and then copy and paste that over to say your email it to yourself, and that way you got the actual time, so you don't have to go through all this stuff and to get the exact part that you want. But anyways, let's jump into a quick personal advertisement so you know how to support the channel, and that way you can help it grow a lot quicker and a lot better than I could do just on my own. Thank you for sticking around during this quick personal advertisement, and if you want to help us out at TechFuseNope in the TechFuseNope YouTube channel, then there are several easy and quick ways to do it. First off, there is a fan fund on the YouTube channel itself. I'm not really going to talk too much about it. It's kind of a new feature, but if you want to check it out, then go ahead and click the top TechFuse and Help icon, and also that will take you to our channel itself where you can check out our other videos, subscribe, and you can also share our stuff. So if you want to help us out, the easiest and the quickest way to do it is simply just by subscribing, liking, commenting, and also more importantly sharing the videos, and just turn off the ad block as you're watching the videos, and make sure the advertisements are allowed to go up. Now, other ways that you can help us out is on the bottom left. You can click on the PayPal button, and that will take you to our PayPal donation link where you can donate a one-time fee for the PayPal. On the right side is the Patreon, and that's a monthly thing, so if you want to donate monthly, then you can go there. In the middle is the Disney, which owns Maker Studio, and if you have a YouTube channel and want to get partnered up, then you can click that, and if you get accepted, then whatever Maker would get out of the cut, I actually get a little bit of that, and you still get to keep whatever revenue as before. But it also helps me out because whatever Maker Studio will get, I would get a little bit of that each and every time, and it helps me build up enough money to get labs and stuff rolling on. But anyways, let's take you back to whatever video that this is, and hopefully you enjoy it. Welcome back. So as far as things goes, I want to mention that real quick. I'm going to glance over some minor things like network portions, host portions, broadcast portions, things of that nature, because I can actually get into another video, shorten up this one a bit, and we can get some fun stuff with that. Topology and all the other stuff. That's probably where I'm going to put it. But as far as this goes, let's try to focus on this stuff and get this done. So what you should be seeing is some IP addresses and a subnet mask and some other stuff. So the IP address, as you see, is 203.0.113.10, and the subnet mask is 255.255.255.0. IP address, it doesn't really matter what it is. It could be, let's even give it mine. My home router internally, it's 192.168.1.1. So as far as this goes, the 203 in this scenario, and same thing with subnet mask. Subnet mask below, you might notice that it's 3 numbers, then period, 3 numbers, period, or 3 numbers at most, and then at least it has at least 1 number, and this is including 0. So each segment is called an octet. So the 203, that's 1 octet. The 0 is another octet. The 113 is another octet, and the 10 is another octet. And the binaries below, if you really count them, it's 8 things. It's an octet. Oct means 8. And this kind of important to note, not too much. The important thing to note is the 203.0.113. That part is a network portion, same thing as 255.255.255. That's a network portion. The host portion is the last bit, the very last bit. And what you'll see on topology, just side note, is a host address, and then we get into sorry about that, a network address, and then a host portion. And I'll get more into this in the topologies, and the reason for that is it makes it a lot easier for whomever's reading the stuff. So as far as what you need to be paying attention to down below is we need to transfer everything from decimal to binary back to decimal. So real quick, this is pretty important also to note, is the network address has a 0 at the end. The host address is anywhere from 1 at the end to 254, and the broadcast is 255. And by the way, there is one part I left out. It's the CIDR that you might notice. The /24, basically, instead of writing out 255.255.255.0 or whatever the subnet mask is on a topology map, then we can just write out /24, and that just shortens it up. It's kind of like IPv6 and IPv4 in general, since it's the same thing. Well, same thing here is the CIDR was made just to shorten that up. And when I get to topology maps, you'll really start seeing that quite a bit. But let's go into the broadcast, host, and network. So the one thing to keep in mind is a network and a broadcast address. You cannot use these. The network and broadcast address is what the network uses. The broadcast is a broadcast address. You have to go one up from the network and one down from the broadcast, because the broadcast is always the most likely on your system is 255 and the network is 0, and that means that you can use any IP address between 1 and 254, and that means that you're on a /24 subnet, and you know, it's just the rules of things. Now, this is where things get very complicated and very interesting, and this is where this part goes over a lot of people's heads, is making the actual subnet and splitting off the IP address in order to make a subnet. So as far as this goes, what our objective is we are working at, say, company X. It doesn't remember. In fact, let's just use mine. We are working at TechFuse now. Hypothetically, we're a major corporation, got a lot of departments, yada yada, and we want each department to be stable and have their own interface, their own network. So in order to make sure everybody's happy, we need to set up a subnet. So when we got the internet service provider to give us a IP address, we need to find a way to split that IP address up to satisfy all or as many departments as possible. So let's say the internet service provider gave us a IP of 203.0.113.0. And what does this mean? Well, it's a network address, which is pretty much what you'll be getting. And you have a choice of using whatever between the actual network and broadcast. So anything between. So from here, what we're looking at is the last octet. Since it's not used, the last octet, it has full range to play with. Because if you look at the broadcast, the last part of it is all ones, which is 255. So we can satisfy 8 departments. Now we're going to get to some math, and this is the extent of it. So we get to 2 to the power n. N is the number of bits needed, and that's very important to realize because this answers how many networks are required. So what we do is use logarithms. So log of the base of 2 to 2 to the power n equals logarithm of log to the base of 2 8, and with that we're able to actually take n out of the equation and actually make it into n times logarithm, or log with a base of 2 to 2 equals log base 2 8, and then we go into n equals 3, so we got 3 bits. However, there is a way around this, so you don't really need to know much math besides basic algebra, because I mean what I just showed you was I went through an entire Aerospace program, I know how to launch rockets. I dealt with NASA, and I don't even know how to do some of the stuff that they want you to do. And I know ways around it, and I'm about to share that with you. So what you should be looking at is a subnet calculator. And you have to make one of these either on the fly or wherever. And I'll advise you what's the best thing to do is if you're on the field, you probably could look it up on your phone. I might actually make an application so you can just download that, and if I do, I'll leave a link below so you can just get it for free and you can have it right there. But for the most part, what you're looking at is having something with you, especially when you get to the test, because you can't, pull out your phone, is you need to know how to make one of these. Otherwise, you're going to have to do that math. And what is the chances that you can actually do that math on, not with a calculator, but pen and paper? Probably not that high. So, here's the deal. We have 3 columns, 3 rows. And first is bits, next is network, and the last is host. So bits, as we saw, it deals with the how many we need and stuff like that. The network deals with how many networks we can make out of it. So I think in the scenario that we're going for, we're trying to aim for 8 networks. I'm not really sure. And the host, that's its own thing. So what we're trying to figure out is how many networks we can get. So in this scenario, where before we found n equals 3 bits, here we could just take a look at it and it says 8 networks. Simple enough. And as far as that goes, what you do to make this calculator, it's pretty easy. On the bits, just start with 0 and add 1 to each line, so 1, 2, 3, 4, and so on. Then on the networks, start with 1 and then double it. So 1, 2, 4, 8, 16, 32, 64, 128, so on and so on. Then with the host, minus the networks from 2. So there is no negatives. You can't have a negative host. So the first 2 is obsolete. We ain't dealing with them. But with the third, which is the networks, is 4. 4 minus 2 equals 2. 4 minus 8 equals 6. 4 minus 16 equals 14. 4 minus 32 is 30. So on and so on and so on. That's how you make it. That's easy way. So pretty much the most math you're going to have to do is doubling the networks. Everybody knows how to count. Everybody knows how to minus by 2. So that's all you have to do is just double the networks. And a real quick trick, in case you are really not that good at math. Networks and host, if you get a odd number, you did something wrong. Just real quick trick. Because except for the first one, obviously the first network has to be a 1. Because here's the thing, when you double something, it's an even number. Just quick tidbit. So anyways, we can use this to figure out this stuff. Instead of doing all this math that I showed you before, we can actually use this simple calculator to figure out how many bits, how many networks, and how many hosts there will be in all this stuff. So when you take the CCNA, where you can't take, I think you can take the calculator at first. I'm not really sure. They might change this around, so keep that one in mind, because they do like to change the stuff around. What you need to keep in mind is you need to be able to do this on pen and paper if need be. And there will be times where you have to do it by pen and paper. So that's a huge thing to keep in mind. But any other time, I'm probably going to make an Android app and also an iPhone app on this particular thing, So you can just take a look at its quick reference and say, oh, this is the number I aim for. But anyways, so I'm going to give you my method on this second, or on this part. And it's very important to realize that this is my method. I figured that this works for me, and it makes it a lot quicker. It makes it a lot quicker. In school and many other places, on the field and everything, they want you to do it their method. The answer gives you the same thing. It's just theirs. For me, it takes a lot longer. For you, that might be quicker. But you do need to understand their method in order to understand my method. Because how I made my method is I actually started seeing a pattern. I was like, wait a second, I don't need any of this other junk. I just need to focus on this one part. So anyways, here's what happens. We take the subnet mask. Simple as that. We take the subnet mask, we take the broadcast, whatever. We take the subnet mask and we take the last octet. So here's what we do is we actually take the last octet and instead of everything else, which what they want you to do, which I want to teach you in a second. And then we take the first 3 bits, the first 3 bits being on the left side. Since we know we need 3 bits in order for our thing to work, we take the first 3 bits. We don't need anything else. That's what we're borrowing. We mark them where we don't use them. Just keep it in the back of your head. We ain't using them. And what we do is those 3 bits, we mark them as 1s. That's it. The rest of them stays the same, stays as 0s. Those stay at 1s. And now the broadcast, what it will be is 255, 255, 255, because remember all 1s is 255. And then our new ending, it was at 0, so our new ending is 224, or known as a /27. Very important to note that. Now what we do is with the broadcast, remember, we cannot use the broadcast, we cannot use the network when we're assigning IP addresses towards our devices. The broadcast is, we have the -1 on the broadcast, and we have the +1 on the network. So in this case, the network ends at 0, and we need to find what the broadcast is. So what we do is we take the broadcast and take the last octet again. Take the first 3 bits on the left side. We mark that as its own thing. We put 0s in those first 3 octets and change all the 0s on the right side to 1s. Now, what that gets us is, try to do a calculation. It gets us 31. So that's our limit. Our local address, we can assign 30 IP addresses in our local address now. So it not only secures it, it cuts down on waste. Because, I mean, there's a bunch of things I can get into right here, but the biggest thing to keep in mind is now that we change our actual broadcast, in fact, you can actually do this on your home network if you really wanted to. Some Wi-Fi routers won't allow you to do this. Some higher end ones will. So that's a huge thing to keep in mind. But for the most part with this, in fact, I'll advise you to actually do this on your Wi-Fi networks if you have a choice, if you only got one band, then there's no reason why not to, because there's a limitation, and on the higher end ones is like 32 devices on the Wi-Fi network. So you can actually, with this, you can actually make your subnet mask a /26, and that'll give you a total of 62 usable IP addresses, or you can just, you know, sacrifice 2 IP addresses and just go with /27, and that way you never will hit beyond the limit, whatever it may be. But also keep in mind, the any device that you plug in physically, plug in with Ethernet, that's going to take up 1 IP address. But that aside, going back to this, that side. So basically, what we did is we found that we needed to borrow 3 bits. We borrowed the 3 bits on the subnet mask. We turned them all into ones. That got us 224 for the last part of the subnet mask. And that changed it into a /27. And on the broadcast, we borrowed the 3 bits again. And on the right side, we turn it into all ones. And that made it into a .31. So we only have between IP1 and IP30 to use. I can't remember what the IP address I was using. I have to look it up. But we have IP address 1 to IP address 30 that we can use. IP address 0, because yes, the numbers actually start at 0 for networking. It's a networking address, and the broadcast, we can't use that. It's 31. Hopefully that was a bit clear. Now, what is the method that everyone else wants you to take? Well, basically what happens, and you'll see this on CCNA classes, CCNA practice things, and all the other junk. What you'll see is they want you to put down the networking address, the minimax, or whatever it may be. Then they want you to put into the subnet mask. So all that's the same. They want you to borrow and they want you to write down the entire thing. And then they want you to borrow the bits, like I done with mine. And then below that, they'll put in the actual network address. It's the same. That doesn't change. I don't see a point in dragging that down. It's just more, you know, wasting time. Then you got the host address, so it starts with 1. That doesn't change. And then you have the max host, and that's you got to find out the broadcast. And they want you to write down the entire broadcast, so the IP address plus at the end. In this case, I think it was /27, so it was 32. And they want you to write that down in the binary form or whatever, and then write down the max host and minimum host, and go from there. I don't see a point in that, since you're only really dealing with the last part. As long as you know which area, like which line is networking, which line is host, which line is broadcast. As long as you know that, you can find this stuff out pretty quickly, and it takes very little to no effort at all. And I find that my way is a bit better. It's not 100% better. It's just speeds it up just a bit, because you don't have to write down the entire IP address, since everything on the left side, everything that is not the host doesn't change. That's the thing. Everything that's not the host doesn't change. In fact, the reason why those 3 bits doesn't change on the networking, the host, and the broadcast is because that is not part of the host anymore. That's part of the network. By borrowing those 3 bits, you now borrow them into the network, and so it eliminates that from the equation. That's very important to note. Now we need to figure out our networks. So we got 8 networks to play with, but we need to make them. So as far as that, it's pretty simple. Just 3 bits that we borrowed. Just put whatever number of the network, so 1. So in binary, it's just 1 on the first right side, and put that all the way down. Then in binary for 2, it's 10. In binary 3 is 11, and so on and so on. And pretty much I got the list right here from 1 to 7, and the other being the 0. So remember, in networking, numbers start at 0, not 1. So as far as the example below, basically that's showing an example of what I'm talking about. So if I want the 0 network, I would just add it all zeros like it originally showed you. However, if I want to program the first network, what I will do is the very first part on the last octet on the left side, remember we borrowed the 3 bits, I would modify that. So the furthest right third bits would be 1. For 2, which in this case it's actually showing 2, in the example it's 0, 1, 0, and so on and so on. So the last 3 octet, or the last octet, but the first 3 bits on the left side, that's what we change from one network to the next. Now where does this play? Well, across the board, it plays with the network, the host, and a broadcast. It doesn't touch the subnet. So that's very important to realize, is the subnet across the board stays as /27 or whatever your subnet would be. So that's the very important part. The network, the host, and the broadcast, that's where this plays in. So now we are getting into the easy stuff, IPv6. Why is it easy? Well, IPv4, it has a limitation to it, and we got to find out all the usable IP addresses and all the other stuff. But with IPv6, chances are you're never going to have to worry about anything like that. So you can bypass a lot of that stuff. The only real reason why you want to subnet is obviously for the security and stuff like that, and you don't need as many things. So as far as this goes, I'm going to skip over a lot of basic things on IPv6, and I might hit that up on a later, most likely I will, in a later video for CCNA, because I can get a little bit detailed into it. But let's jump into the subnet part. So with IPv6, there's 3 different parts to the address. You have a global, then you have a subnet ID, and lastly, like before, you have the host ID. And by the way, the global prefix is, the first part is what your internet provider or whomever gave to you. So that in case you're wondering. Now, just to give you a fictional IPv6, let's just say it's EA70 7792 for the global, and the subnets, it's all zeros, so there's our first one. And we can have pretty much how many we want, but what we need to do is, we don't want that many, so we're just going to limit it down to 4. So we have the first one automatically right there. And we're going to borrow from the host. So now what we're going to do is just, the next one, just do 1, 2, 3 at the very end, as seen on the thing. And it's just borrowing from the host like before. I mean, it's pretty easy. And the reason why it's easier is there's abundance of IP addresses, so limiting things down by the address won't really be a problem. You most likely will never have to actually sit down and actually calculate the stuff like you do on IPV4, because there's a limitation again on the IPV4, whereas IPV6 there is a limitation, but it's so high. It's not really realistically reachable right now. Now that's pretty much it as far as subnetting. The main fact is the tests, as far as I know, because it changes per time it's taken. And the test, as far as I know, it's focused more on IPv4 than IPv6, but there will be some IPv6 for the most part. So it's important to know both, but more so on the IPv4 side. And no one's expecting you to know all this stuff by heart, not even on the test. They're not expecting you to know, and I got in front of me the actual numbers of the subnet, the usable IP addresses. And by the way, when you're actually going through this stuff, I advise you actually go and have a piece of paper, not with you on the test, but anywhere else, that says the subnet, the usable IP addresses, and so on and so on. There's quite a few useful charts out there. But the most amount of usable IP addresses you can get with the subnet stuff is 4,294,967,294 usable IP addresses. And that is not counting the 2 for the broadcast and the network, which will bring it up to 296. So yeah, that's a /0, by the way. And then you can get all the way down to 1 usable IP address, and that's a /32. So that's pretty important to note, as far as they're not expecting you to know that. What they're expecting you to know is how to make that table so you can figure this stuff out. Because you need to be able to write down the scientific the subnet calculator and make your own subnet calculator, figure it out very quickly, or actually know the math formula and know how to do it by heart. Because remember, you got to get that test done. And that's pretty important notes. So you're not expected to know how many actual usable IP addresses walking in the door. They ain't gonna say, what is the amount of usable IP addresses for, I don't know, /14 or 255.255 or 255.252.00, which is /14, and you're supposed to say 262,400 or 142. No one's expecting you to say that. They're expecting you just, being able to make your own subnet calculator and do it then or there. It's easy stuff. But anyways, if you felt like I missed out on anything, if I should add any more information, or you can give a better explanation on some of this stuff, because it's very important, because again, if you don't get this, you will fail the test. There is no ifs, ands on that. So if you don't get this, then try to get a couple sources, practice, ask questions, ask me questions if need be, and I'll help you out and ask other people questions. I'm not going to do no study group though. But if you feel like there's a better way to explain some of the stuff, go ahead and comment section. Felt like I missed out on anything, also put it in the comment section to help people out, because this is the more important things in CCNA. Now, if you got any questions, again, leave that in the comment section and I'll try to get back to you as quickly as possible. And also on top of that, if you have any tips on other videos you want to watch or want some explanations on something else, go ahead and leave that in the comment section. I'll try to help you guys out as quickly as possible on that. Now, if you like this, please leave a like, please subscribe, and please share. Please visit my other videos, and also, more importantly, share my stuff so more people can see it, and that way I can actually make better stuff over time. And also, please feel free to visit the Patreon campaign, the PayPal donations, the Maker page if you have a channel that you want to sponsor, and anything else I have link. But anyways, it's been Craig Bennett, founder and owner of TechViewsNope, and I hope you have a great day, and I hope that this actually helps you out during the CCNA, because I know I will be reviewing it when I go for my CCNA.